Alright, so let's talk about this trig function that I had mentioned earlier, the sine of x, and we could do this with cosine if we wanted. And we're in degree mode here. So basically, the sine of x in and of itself is a function, right? So what we want to do is we want to test if this is one-to-one. So basically, if I look down the x's, there are no repeats, okay? And that is fine. That means that this is a function because there's not, well, if there's no repeats for x, there's no possibility that there's going to be more than one y value. So basically, I'm going to sketch this, and I've made this a really tiny grid because I am going all the way up to 180 to show you the inverse. So this is not going to be to scale by any means, but we're going to try. So it's going to look, barely see the curve. It's -1. Oops. I should go down a little more. Let me try this again. I'll just exaggerate it a little bit. Oh, goodness. One more time. Here we go. There we go. Okay. Kind of not the best looking, and my graph is really crooked, so that's why it kind of even looks more odd. This is the x-axis right here, like that green, that curved line. So sine of x is definitely a function. If we go to find the inverse, we're going to swap out x and y. And then we're going to use what we know from our trig unit. So this is the arcsine of x equals y. Okay, we could try to find those values, but we know what they're going to be. They're going to be these flipped. So I'm going to have 0, 0, 190, 0, 180. And I'm going to stop right here because look what happens. 0, 1. So I'm fine here, right? But then I'm going down, right, to 180 from 1, and look what happens. I have these y values, and look, the y values start repeating. And I can tell that they're repeating because I'm going back down and I'm hitting 0. So basically, this is an inverse function if we restrict the domain only. And what we need to do to restrict that domain is if we thought of our unit circle, right? Sine is the y on the unit circle, right? If we go this way, none of the values repeat until they hit 90 degrees, right? And then the sine of any degree after that, well, this and this we know are symmetric, so they have the same y value. So definitely, after 90, we start seeing a repeat. So basically, if we restrict the domain that x is greater than or equal to 0 but less than 90, and it has, or less than or equal to 90, sorry, we definitely have a function, or a 1-1 function, but any extension on that would not be 1-to-1. Okay, so if I were to graph this, I'm at 0 here, and I'm going to go up to 1 on 90, and this would be my function. That would be the graph of a 1-to-1 function for sine. Okay, and I don't need this part because this part would not be 1-to-1. So really, if I look at this, these are my two inverse functions. And like we talked about, you have, if we were to draw a line through these, okay, you can see that they're reflected about y equals x. All right. So a lot of the time, and I know I've said this, but this is really important, a lot of the time we can achieve 1-to-1 functions if we restrict the domain, okay? So there are some things that definitely don't, you definitely know they're not going to be functions, like for instance, a parabola, right? If we have a parabola, right, so it's 1, 1, 2, 4, 3, 9, right? And if we flip it to the side, right, we end up with 1, 1, 4, 2, 9, 3. That's great, right? So this is my original. This is my inverse. But watch what happens. What happens if we do the negative numbers? So we also get -1, 1. We get -2, 4. -3, 9. Check this out. If I add these to my list, look what happens for the inverse. I now have two values for 1, right? And that's why we get this graph that looks like this. So these are the negative values. Well, if we include the inverse of y equals x squared, right, which is plus or minus the square root of x equals y, it's not a function. But if I restrict my domain and I say that x has to be greater than or equal to 0, that eliminates these, okay? And it eliminates this. So then we have a one-to-one function, and look, it meets our rule that it's reflected about the inverse and its original are reflected about the graph y equals x. So I think that is the basics of inverse functions. So that is all for today. We've learned how to find an inverse function. Okay, and we've determined if a function is one-to-one. And I actually should throw one more thing in really quick. If I have f of x, oh, except we're not using that notation. If I have function f like this, and I have, we'll just do 4x minus 8, and I say find the inverse function f of -2, what this means is that my first step is to find the inverse. So I'm going to rewrite this as such. Okay, I'm going to swap x and y. Okay, and at this point, if I want to, I could put -2 in for x, okay, because it goes in for x after you've done the inverse, or I could solve for y. So I think I'm just going to go ahead and plug it in for x. So I end up with -2 equals 4y minus 8. So add 8 to both sides. I get 6 equals 4y, and y equals, ooh, I've run out of room, 3 halves, okay? So I could say the inverse function of f when x is -2 equals 3 halves, or I could say the inverse function of f such that x equals -2 within a domain is 3 halves. Yields a result of 3 halves. Either one of those is fine. Okay. Alright, so that is all for this lesson.